Okay, so I'm a research scientist and my area of research is cancer cell biology, and I'm based here in the NICB in Dublin City University, and there are a team of us here working on cancer research, and several of the team are funded by CCRT and also by the Caroline Foundation. I myself was the Caroline Foundation Fellow for 2 years, and now Alison Murray has taken over that position, but I am continuing with the cancer cell research, and it's really focused on trying to find new treatments for cancers. We do a lot of work on breast cancer, but we also work in other cancer types such as melanoma and pancreatic cancer. So for a scientist working in the lab trying to find a new drug for a particular type of cancer, or let's say a subtype of breast cancer, which we would work on, they will work with cells in the lab which were originally taken from a patient's tumour, and we can grow those cells in the lab in small little flasks, and they will keep growing, and so we can grow the cells in the flask and then add the drug to the cells and see, we can measure what effect does that drug have on those cells. And so we can test one drug on its own, or we can look at combinations of drugs and see, let's say, does an old drug that's already available work well with maybe a new drug that's becoming available from a drug company, and does that combination work well together or does it not work well together? And so that can help us to optimize new combinations of treatments for particular subtypes of cancer. And we don't just rely on, one cell line, we call them. We have multiple cell lines so that we're testing the drugs across a range of different tumour cells to make sure that we're trying to represent the individuality of a patient's tumour as well, that we're not just looking at one cell line, we try to test in a large panel of cell lines. So an example might be HER2 positive breast cancer. A lot of people might have heard of HER2 positive breast cancer, and it's treated with a drug called Herceptin. But even though maybe 15 to 20% of breast cancer patients will have this HER2 positive breast cancer, they don't all behave in the same way. So they might all receive the drug Herceptin, but they might not all respond to it. So then that's where the individuality of the tumours comes into play, that some tumours will respond and some tumours won't respond. So what we need to try and do is figure out which ones will respond and how can we predict which ones are going to respond to Herceptin, let's say, and which ones might need a newer treatment approach to overcome that resistance to the Herceptin. And so we can do that by looking at the patient tumour samples and looking at the profile of that tumour, what proteins are expressed in that tumour that might be potential targets for new drugs coming online that might benefit those patients if they're not going to respond to the existing drugs like Herceptin.